Welcome to this series on hints of a random variable. So in this, we'll try to study the concept of variance. In one of the previous videos, we looked into the concept of expectation of a random variable. Similarly, variance is also one of the important concepts in statistics. And why do I say so? Why does variance matters? Let's look into that. So let's imagine that there are two friends standing near a lake, and one of the friends suggests that the other one can cross the lake because the average depth of the lake is 4 feet, and because the other one is 5 feet, so they can easily cross the lake. Now, if you notice the lake, it some at some place it also has a depth of 7 feet. So, isn't the suggestion of crossing the lake because the height is just 5 feet and the average is 4 feet a riskier suggestion to have? Let's take another example. So, let's say we have two restaurants, Pengu Pizza and Pizza House. The delivery time for each, for let's say Pengu Pizza is given by these numbers, and for Pizza House it's given by these numbers. Now we go to DoorDash and try to place an order where on DoorDash the average ETA for both these restaurants show as 25 minutes. Now, when we're trying to book which restaurant we can rely upon, or which restaurant should we be choosing so that the order can arrive at the earliest, or we can hope the order arrive at the earliest, or we can avoid the risk of sleeping empty stomach. So, what is the problem with these two examples? So, here we see that swimming or crossing the river by just considering the average depth might be a riskier thing to do. Similarly, selecting the restaurant just based on the average ETA might be unreliable or less uncertain. Let's take another example. Let's say if you're packing for a trip, just considering the average weather conditions or the average temperature conditions might not be sufficient information. We rather might require the variability in the weather or the variability in the temperature throughout the day or throughout the week to better plan a trip or to better decide what kind of clothes should we be taking with us, depending upon the weather conditions or the variation in the weather conditions. So let's see how we actually define variance in that case. How can we measure that variability or variance? So variance is measured by how far things are from the average. It tells that about the spread or the dispersion of data points around the mean. So let's say if you take this example, we have a few points, and let's say if the mean is this green dot, and we calculate the dispersion or the spread or the deviation around the mean. So this would become the spread of these data points. And similarly, in this example, we can see that the spread is a little lesser than as compared to this case. So we can see that the variance in this image is less than the variance in this image. Similarly, if we take a data distribution like this with a mean mu here, we can see that the variance or the spread of this distribution can be given by this spread. Uh, so mathematically, we can define that the variance could be the average or expected squared deviation from the mean. Now, because we were calculating or we were measuring some notion of spread or dispersion, we can have that from the concept of deviation. Now, deviation can also be calculated in terms of just taking the distance from the mean. Sorry, in this case, we can just simply take x1 minus m or x2 minus m, and we can simply divide it by 2. The problem in this case would be that if there are like positive and negative deviations, they can simply cancel out each other, and the total deviation or the variance rather could just become zero. So why not take a mod of it? So that actually is a thing that we can call it as mean absolute deviation, but we are not going to be discussing it right now. And so just to make things a little easier, we'll try to have the square deviation that helps us in different mathematical calculations, and as well as this is differentiable. So now to define that, we'll be calculating variance as the average or expected squared deviation from the mean. Now, let's take this example of dart. We can see that again, these are the points that are having low variance, and these are the points that are having high variance. We can also notice that these specific set of points are more consistent as compared to the points on the right hand side. We can ignore the fact that maybe these points are not there at the expected position, but they're still consistent enough as compared to these points. So what we have learned from these examples, that variance would give us some notion of consistency, or whenever we want to study the consistency or the variability or some notion of risk or spread or dispersion in the data, we try to look into the variance of the data samples or the data that we have. So in this series, we'll try to deep dive into statistical moments, or where variance fits in the realm of statistical moments. So we have seen that mean is probably just not enough, or it's not giving enough information, where we also require variance. Similarly, we'll have other statistical movements that can give better understanding of the data distribution that we are trying to study. Next, we'll also look into the formula for variance, or how we can calculate variance based on some data samples that we have. That in turn would depend on whether the data samples are coming from a population, or we are or they are being fetched from a subset of that population. We'll also look into estimate and estimators, where estimators are required to infer the reality or the truth just by the available data that we have. We've also seen that sometimes we divide by n minus 1, or sometimes we divide by n while calculating the variance. We'll look into the answer why is the case when we'll try to demystify the Bessel's correction. And finally, we'll try to study some subtle differences between variance and entropy, where variance and entropy both capture some notion of spread of a data distribution. So with this, we can see that variance is an important concept being used in different domains like finance, statistics, machine learning, sports, or wherever there is some involvement of data and we have to study the characteristics of data. For example, if we have invested in two different stocks, S1 and S2, and they are giving the same average return, there might be a case that we are a bit more worried about stock 1 than stock 2 because of the volatility in the prices of stock 1 as compared to stock 2. So we can see that the mean simply hides the chaos that we have, and in the series we'll try to expose this chaos by studying variance and other statistical movements. Thank you. So we'll see you in the next video. Till then, happy learning.